Okay, so let's say that I give you a mean of 71 and a standard deviation of 4. The first thing that I would do is draw out my bell curve. So I draw out my line, my curve looking like this. Mean I know is right here in the middle, which is 71. I'm going to go 1, 2, 3 standard deviations to the right and 3 standard deviations to the left. So since it is, each tick mark is a standard deviation, I'm going to take that value 4 and add it to my mean on the right side. So I get 75, 79, and 83. Then on the left I subtract. 71 minus 4 is 67, minus 4 is 63, minus another 4 is 59. So there we go. So I could ask you, okay, what is the percent that is greater than 63%? And I would say, all right, well, let me first identify the fact that this is where 63 is. So I'm going to use my empirical rule and first break all of these into those sections. I know that I need everything on this side because I said greater than 63. So I'm going to take this 13.5 and I'm going to add it to 34. And I'm going to add it to this 34 plus 13.5 plus 2.4 plus 0.1. And when I do that, I get 97.5%. So that means that a score of greater than 63 is 97.5% of the data. Now, you could use your Z-score for this in the formula. And if you did that, this is what you have to be careful of. If I did that, I would want to do 63 minus 71 divided by 4. And when I do that in my calculator, I get -2. And that makes sense because I told you that each standard deviation is 1 Z-score away. So this is 1 Z-score, this is 2 Z-scores, and since we're going to the left, we know that it's -2. So when I look at my Z-score table, that chart of all those numbers, I'm going to go to -2.0 and the first column, which is 0.00. And when I do that, I get 2.28%. Now, keep in mind, when you use this table, you are talking about the percentile, which means that value and everything lower than it. And since I asked for everything greater than 63, you're going to have to do 100 minus 2.28. And when you do that, you get 97.72. So, these two values, or these two percents, 97.5 and 97.72, are different, but know that when we talked about this, if you're using your Z-score table or this chart of all the numbers and all the percentiles, it is a little bit more precise than just using your empirical rule. But both of those answers are acceptable. Okay, so let me ask you another question. What percent of the scores are less than 75? Well, if this is where 75 is, less than 75 is all this part here, this whole percentage. So, using the empirical rule, if I just chunked everything, then this is 34%, this is 34, this is 13.5, this is 2.4, and this is 0.1. So that is what we are adding together. And when we do that, we get 84%. So 84% of the data is less than 75. Okay, so that was using the empirical rule. If you decided to use your Z-score table, you can do this, of course. I personally, since I'm giving you one that is a whole number Z-score, would just use the empirical rule. But if you're the person who likes to use the Z-score table, then this is fine. So you would do 75 minus 71 divided by 4. When you get that, you're going to get 1. And this makes sense again because we are one standard deviation away from the mean. So in my table, I'm going to go to the positive side at 1.00, and I get 84.13%. Again, both answers are acceptable. One is a little bit more accurate, and this represents 84% of the data. Now, the one before that we did, I said greater than, and then we had to do a little subtraction problem if you use the z-score chart. But a percentile, which is what the chart is giving you, includes that number and everything less than it. So everything less than 75 is 84.13. So since I asked for less than 75, you don't have to do a subtraction problem. You only have to do that if I want data that is on the right side. So a percentile gives you always below that value. Okay, now if I want to know the percentile of, let's say, 72, that means I want to know how much better is a score of 72 if these represented scores of tests or something. So since 72 is not one of the values here in purple, then that means we have to use our z-score table. So we're going to do 72 minus 71 and divide it by 4. And when you do this, you get 2.25. So then you go to your table. On the positive side, 0.2, and then you go over to 0.05. And you get 59.87%. So the percentile for a score of 72 is 59.87%. Okay, so then if I asked you, what if I want the percent that is greater than a score of 80? So similar to what we did before, but since 80 is not a whole number standard deviation away from the mean, we have to use the z-score table. So 80 minus 71 divided by 4, and we get we get 2.25. So I look in my z-score table, 2.2, and then I go over to 0.05, and I get 98.78%. But again, I said greater than. So that means if this is where 80 is, right here, I want everything greater than it. So we have to do 100 minus 98.78, and that gives us 1.22%. This is the answer because, again, percentile represents everything below that value. So if I got a score of 80, and that means that I'm in the 98.78 percentile, meaning I scored equal or better than that many people, or that percent of the population. That's awesome. Then that means that I'm only less than 1.22% of this population. So another problem I could say is, okay, well, what about in between 70, let's say in between 67 and 75? Well, this should be quick. I would use the empirical rule for this and say, oh, well, I know this. I don't have to find any z-score table. One away from the standard deviation on both sides is 68%. So 68% represents a between percentage. Now, what if I wanted to find the percent between, let's say, 64 to 73? All right, again, those scores are not a whole number z-score, so I'm going to have to use my z-score table. And I'm going to actually have to do the formula twice and look on my chart twice because I have two bounds. I have a lower side, 64, and an upper side, which is 73. So 64 minus 71 over 4. And I get negative 1.75. I look in my chart on the negative side, negative 1.7 over to 5, and that gives me 4.01%. Okay, now let's do the upper side. I'm going to have to do 73 minus 71 over 4. And when I do that, I'm going to get 0.5. And looking on the positive side now on my chart, I go to 0.5 and then just 1 over because it's, 0.050, and I get 69.15. So these are the two bounds now as a percentage, and I wanted to know the percentage in between these two. So I'm going to do 69.15, and I'm going to subtract 4.01 from it, big minus small, and that means between these two values here, there is 65.14% of the data. That's how much data is in between these two intervals. So you have to remember, what is it asking for? Is it asking for data in between two values? Is it asking for data above or greater than or less than, or am I going to have to use my empirical rule? Can I? Is it a whole number? Z-score. Do I have to use my Z-table chart if it's not a whole number? Do I just like to use my Z-table chart? Or Z-score chart, sorry. So all those questions you need to be asking yourself and figure out what works for you. So I hope this helped, and yeah, if you have any questions, let me know.